Assalamu alaikum everyone, and today we are going to be talking about reaction mechanisms. Now we've learned a lot about reactions, but what is required for a reaction to occur on the molecular level? Collision theory says for molecules to react, they must collide in the correct orientation and with more kinetic energy than the activation energy. The activation energy is the amount of energy that has to be provided for a reaction to proceed. And as this theory says, it must be collided with in a very specific manner. Otherwise, it will just bounce off, like I said in my previous video about kinetics. As for energy, let's refer to a diagram. Now here, higher up in the y-axis is energy, and further down the x-axis is further in time. And as we can see here, there is an activation energy, and it's just over the transition state. In my SN2 video, I said a transition state is the middle of the reaction, but actually this is the orientation. Once reached, the reaction will certainly occur. And energies less than this will not give a reaction. We can also see the delta H, or change in energy from reactants to products. Now, if the products sit low in an energy diagram, it is an exothermic reaction which releases energy. And if the products sit higher in the energy diagram than the reactants, then it is an endothermic reaction which absorbs energy. Now, some people say catalysts increase the rate of reaction. Now, this is often true. The correct definition is the catalyst lowers the activation energy of a reaction. Let's look at this diagram here. As you can see here, a catalyzed reaction in the energy diagram has less activation energy, so there will be more success for the reactants to react with each other and turn into products. But the uncatalyzed ones is the one that has the same activation energy, so there will be less success to reaching the transition state. Now, catalysts do not affect the delta H and are not used up stoichiometrically. Also, higher temperatures lead to more success with reactions. This is because the higher the temperature, the faster the molecules move with one another. So there is a higher chance for them to collide. And that's because the more kinetic energy there is, it will be easier to surpass the activation energy. The Uranium Equation shows how the rate constant depends on the activation energy. And we can modify it to this equation where we can see the ratio of the rate constant in a reaction at different temperatures. And this is what we can use to calculate the activation energy. Now, in this equation, A is the frequency factor, E is the E we talked about in our algebra series, EA is the activation energy, not electronic arts, R is obviously the gas constant, and T is temperature. And then a balanced chemical equation can tell us about the reactants and the products, but in the molecular level, it's a bit more complicated. There are many series of steps, and the series of steps are called a reaction mechanism. Yes, this is the main topic of the video. Reaction mechanisms. Now, the slower reaction mechanism is called the rate determining step. And that's because the rate, for the most part, depends only on this step, as the other step is so fast they are negligible in comparison. Now, if a species is found in an elementary step, but not in an overall equation, it is called a reaction intermediate. Now, that's all there is to it, to the video. If you want more videos about chemistry, make sure to subscribe and leave a like down below, and comment if you have any confusions with my videos, or if I missed anything, or if I did any wrong calculations, or made any error in general. And thank you for watching, and I will see you next time. Bye.